Alright, so I want to find this integral, and I can see that certainly because this is being multiplied, this is going to be integration by parts, and there's actually a rule that we need before we can do this. So if I just look flat out at ln of x dx, I could write this as ln of x times 1 dx. And then I can use my integration by parts. So we remember our integration by parts is this whole u dv equals uv minus the integral of v du. My u in this case, looking up here, I'm looking at this one. So my u equals ln of x. My du then, of course, is 1 over x dx. My dv, in this case, is this piece, my 1 dx. So dv equals 1 dx, which means v would have had to be x to be able to find the antiderivative of just 1. So putting it in this, well, not that one, this format is I'm going to have ln of x times 1 dx equals my u, ln of x, my v, x, minus my integral of my v, x, my du, which is 1 over x dx. So all I've done here is I've taken and I've plugged all of these values into this formula. And so certainly I can do some rearranging and make things look a little bit better. So this is simply going to be x ln of x minus, those cancel, so I just get dx. And then when I take find the antiderivative of dx, or you can even say 1 dx if you want, I see that I get x. So this is a formula that you need to know of when you find the antiderivative of ln of x. So I can use this now going back to this problem. So let's go back to that problem. I'm going to need that piece, meaning I have ln of t, and this whole quantity squared dt. My u equals the ln of t quantity squared. So my du, using the chain rule, would be 2 ln of t, and then of course times the derivative of the inside, which would be 1 over t. And in this case here, if I do that whole business that I say times 1, then I can simply say that my dv equals 1 dt. And so then of course my v would equal t. So kind of doing the same thing that I did up there above. So using integration by parts now is I'm going to take this and put it in my formula. So again, my formula, uv minus integral v du. So I just look up here and I start plugging things in. U ln of t squared. V is t minus v, which is t, and then du, which is all this business. So du is times 2 ln of t times 1 over t dt. Now as you can see, this t and that t is going to cancel, and I'm just going to kind of rearrange this. I'm going to write the t first. So t ln of t quantity squared minus, I have still a 2 left, and I have ln t dt. So as you can see, we're now to why I said you needed this proof up here, because we're now to that step. So in this case, I can rewrite this now as t ln of t squared, and then minus ln of t 2t. So I'm doing my integration by parts. In fact, I'm on this step right here. So I'm just kind of copying that step. And then minus my integral 2t times 1 over t dt. Okay, so once again what I'm doing is I'm going back, and you probably could have skipped a step and just basically wrote this out, but I'm going back up here, so that's where I'm getting ln of t. In my case, I don't have just a t, I have a 2t because the 2 being multiplied out front. And then I also have the integral piece, the 2t times 1 over t dt. So continuing right along, I'm going to end up with then t, none of this stuff outside here is changing, and then minus ln of t 2t, so I ain't do anything there, and then minus, well in this case I might as well do some canceling, so I really just end up with the integral of 2 dt. And so I still have t ln of t squared. I'll distribute that negative. I probably could have done put the 2t first, so minus 2t ln of t, so that's just that piece. And then if I integrate or find the antiderivative of 2, that's going to give me 2t, but notice I've distributed the negative, so this is going to become a positive, and then plus c, which gives me my final answer. So kind of the key to this one is you had to have known this formula up here, because if you didn't know this formula, then there's no way, and what you're doing is you're just doing the same thing, is you're taking that formula and you're using it, in this case, you're using integration by parts again, because you're ending up with an ln of t. Instead of times 1, it's just times 2.